Hi, in this video we're going to discuss how to insert nodes to a linked list, but how to insert what we call an interior node. In other words, it's not a node that is going to end up at the front of the list. It's not going to be a node that ends at the back of the list. We have other videos in which we discuss inserting at the front of the list and inserting on the back of the list. If you haven't watched them, please do so. You don't have to do them in order, but it will be important for you to watch all of them. So in here, the basic idea is we have a list that has values in order, let's say alphabetical or increase in order. We're given a new value and we want to preserve, we want to maintain the order on the list. So we need to insert in order. It's called an interior node. So typically the picture of the linked list looks like this, nothing new, right? It's a bunch of nodes linked to each other. The reference refers to the node that follows, is the next reference. And then we have an external reference that is called front or head that gives us the address of the very first node. In addition to the linked list, then we're going to have a new node that has been properly initialized. This is the node that we want to insert. Its next field is set to null because it's not connected to anything. This is a single node, not a linked list. And we have an external reference that tells us where that node is. Typically, this is a temp reference or it's a new node reference, but the bottom line is we need the reference. So somehow we are going to find a way to traverse the list and find the place of insertion where the node should go. Here is a picture of what happens, right? So assume that we have a collection of integers like the one you see here, and they are in increasing order. And now we're giving the value 31. So we need to insert 31 into the existing linked list and preserve the order. In other words, the picture shows 31 should go in between 26 and 54. Now here you see that there are some things called step 1 and step 2. We're going to talk about those a little bit later. In order to insert this node into the list, I'm going to have to use 3 references. The first one is, of course, we need a reference to the new node. And again, in this picture is called temp. In the picture that I showed you before is called the new node, right? So that's what we have. Then we're going to need a second reference, which is the one that is going to refer to the node that will eventually precede the node that we are inserting. In other words, the node that goes before the node that we want to insert. So here in the picture, 26 should go in front of 31. 26 precedes 31. So here we have this previous referring to that node. And the third reference is a reference to the node that should follow the new node that we are inserting, and that normally is known as current. So in the picture, you can see that current refers to 54, and 54 is going to be the node that follows 31. So we have 3 external references that are going to be very helpful in finding and inserting the node into the list. So let's talk about the steps. So the first step is to traverse the list using the reference previous and current that we just described to find the place of insertion. So this is a different diagram. So notice here that we have a very short list, 12 and 24. They are in order, and we want to insert 14. So notice how current is looking at the first node and previous is being set to null. I'll explain why this is in a couple of seconds. And then we start traversing. Of course, this is not a very long linked list. So as soon as we get to this point, we know that the new value, which is 14, it should go in between 12 and 24. Also notice that previous referred to the node that precedes 14, and current refers to the node that follows 14, which is in this case is 24. So the second thing that we're going to do is once we find the place of insertion, we're going to connect, to link the new node to the existing list. So in that case, we want to connect 14, the new node, to the existing list, but now we know that it should be connected to 24. The third step will be to link the rest of the list to the new node. And for that, we're going to use previous. Previous, okay, is referring to the node that precedes the new node. So somehow we need to connect this to 14. So in this, you see that 12 has been connected to 14 using the reference previous, and 14, which is the new node, has been connected to the rest of the list. So let's review the code that will implement this operation. So typically it's a method. I call this addInteriorNode. And again, let me warn you, if you look this on different textbooks or on the internet, there are different variations, different versions of how to implement this type of method. One variation could be the type. In this case, obviously, it's void, but you could return an object. Another variation is the numbers of parameters. Here, I'm passing a reference that refers to the new node. It could be that you have a second reference, one that tells you where the beginning of the list is. It could be that instead of reference to the new node, you pass the object, and then you have to create a node and assign a reference to it. Again, different ways of creating or implementing the same method. So let me start with this section of the code that matches what we have just discussed. So the first step is to create two external references, one called current and the other one called previous. And the trick about these two is that we need to maintain them exactly one node apart at all given times. So when I'm starting to traverse the list, my choice for current is to start at the beginning of the list. So I assign to current the value front. Remember, front is a reference to the first node in the list. Now, what about previous? So it's not obvious that previous should be null, but if you think about what I just said, which is they have to be exactly one node apart from each other. If current is looking at the first one and previous have to be behind it, there is no node preceding the first one. So my only choice is to set this to null. That explains why in this picture you see that current starts by looking at the first node and previous is being set to null. So previous is exactly one node apart from current, and it is always behind or following current. And then what I'm going to do is, as indicated in step number 1, is I'm going to start traversing the list to find the place of insertion by moving both previous and current. So the second important part of this code is the while loop. What is this while loop doing? Well, simply it's traversing the list, starting with the first node all the way to the last one and trying to find the place of insertion. But essentially what it's doing is finding two nodes, the node that is going to follow the new node, the node that is going to precede the new node. So for that, we're going to use the two references that we just discussed, and notice what I do. Every time that I advance to a new node, okay, I do this in two steps. The first step is to update the value of previous. So previous now has the same value of current. So after this statement, I have two references, both previous and current, looking at the same node. Now, what do I have to do? I need to advance current exactly one node. Well, so I'm going to assign to current the node that is next to it, the one that follows node. So what this does is to advance previous exactly by one node, and for a brief moment, they both previous and current has the same value, and then after that, I advance current. And I keep doing this as many times as I need it. Advance previous one node, and then advance current one node. Advance previous one node, advance current one node. So let's talk about when this loop is going to stop. There are two conditions. One condition is when current reaches the end of the list. Okay, we had seen this condition before. We saw it in a while loop when we implemented a method to count the nodes on the list. We saw it also in a different while loop when we were traversing the list to print all the nodes. So notice that here we're doing the same thing. To find the place of insertion, we may or may not have to traverse all the nodes. So the condition is consistent with other situations that we discussed. Now, we need to find the place of insertion. How do we decide what the place of insertion is? Well, we need to compare values. We need to take a look at the values in the existing list and the value that I want to insert so that we can decide what the correct place of insertion is without destroying the order of the list. So let me go back here. This is a very short list. So I need to take a look at the values 12 and the values 24, which are the ones on the list, and sort of compare them with 14 so that I decide where to insert 14. Well, obviously, if I want to maintain the order, 14 shouldn't be in front of 12. 14 shouldn't be after 24. 14 has to be in between 12 and 24. And the other diagram that I have is a longer list. So again, I'm going to start at the beginning of the list comparing 31 and 17 and then decide whether or not I should insert 31 in front of 17, and the answer is no. Should 31 go in front of 26? The answer is no. Should 31 go in front of 54? And the answer is yes, because 31 is less than 24 and is greater than 26. So I need to keep asking questions using the values of the nodes that I have on the list and the value of the node that I want to insert. That's exactly what the second condition in my while loop is doing. So what I'm doing in this while loop is asking, compare the value of the new node, and for that I'm using the same accessor, get data, with the value that I'm looking at, which is the value referred to by current. And I have this condition here, right? So I need my new value to be less than the one that I'm looking at. And when that happens to be true, that is less than, I found the place of insertion and it's going to stop. As long as the new value is not less than, in other words, is greater than or equal to the value that current is looking at, I have not found the place of insertion. So what do? Advanced previous, advanced current, keep them separated exactly by one node. The loop eventually is going to stop, and there are two conditions. It stops because it reached the end of the list, and that means that the new value should go at the end of the list. The new value that I'm inserting is greater than all the existing values. Or the loop is going to stop because this condition becomes false. And when this condition becomes false means I know where to insert the new node. My new node should go in front of the node that current refers to. So that's a step number one, that was to traverse the list to find the place of insertion. The second and the third steps are going to be, connecting the new node to the existing list. So my second step is to connect the new node to the rest of the list. So in here, I know where my new node is, right? I have a reference referring to. So I need to change the next field of that. And I need to make that next field to refer to the same node that current refers to. So notice that current is referring to the node that has value 24. So I make this next refer to 24. The third step is to connect the rest of the list to the new node. So what is the rest of the list? The rest of the list in here happens to be just 12. So I need to connect this 12 to the new node. So how I'm going to do that? I need to change the value of this field, the next in the node that has value 12. And to have access to that one, I'm going to use previous. Okay, so I'm going to use previous that refers to the node that precedes the new one. And I'm going to use the next field to refer to the same thing that new node refers to. Okay, now my second and my third step, using a different diagram, are called here first and second. First and second because the diagram already shows the place of insertion. I traverse the list and I decide that 31 should go in between 26 and 54. So what is next? Connect, link the new node to the list. So I need to change this reference from being null to refer to the same thing that current is referring to. So 31 now is linked to 54. And the last step will be to connect the rest of the list that should precede the new node to the new node. So again, I need to change this reference that is next in this node, and I need to make it refer to the same thing that in this case temp is referring to, which is the new node. So this is going to link 26 to 31. So current and temp are used to connect 31 to 54. Previous and temp again are used to link 26 and 31. Okay, so that's in my code is this section here. Okay, I need two statements. One that says connect the new node to the rest of the list. Change the next in new node to have the same value as current. This links new node to the current list. And then connect the list that precedes the new node to new node. So now I'm going to use previous change its next to have the same value as new node. So these two statements here are doing what in this picture are known as step 1 and step 2. And they have to be done in that order. I encourage you to try this code and alter these statements, and you will see that things do not work correctly. What about the rest of the code? What is this section of the code doing? Well, we're talking about inserting interior nodes, but we really don't know where the node is going to end up. So what are the special cases to consider? Well, there are two special cases. One is what happens if the list is empty? Then the node should be inserted at the very beginning, right? And then what happens if the value that we are inserting is so small that should be inserted at the beginning of the list? So now we're talking about an insertion at the front of the list. So we need to include those two special cases in my code. So here is the first part. If the list is empty, its front is null, then I simply assign to front the same value at my reference called new node. No need to traverse, no need to have a loop, I'm done. The second special case is what if the value that I want to insert, the value of new node, is so small that should go at the very beginning of the list, okay? So I'm going to compare it to the value of the first node, and that is from.getData. So if this statement is true, this Boolean expression is true, then the new node should go at the beginning of the list. So this is simply an insertion at the front of the list. So what do I need to do? I need to connect new node, okay, to the current list that is being referred to by front, and then I need to change the value of front because I got a new value at the front of the list, okay? So this is an insertion in an empty list. This is an insertion at the beginning of the list. And this is the part that really does the insertion in order for an interior node.